Today, I'm going to show you how to get Azure OpenAI to use your own data through a RAG, and you will see it's easier than you think. Hi everyone, I'm Lionel, your MCT and MVP, and in this video is part of my Azure OpenAI playlist. Today I want to show you what a RAG is and explain it through a simple example. By the end of this video, you will see just how powerful and accessible this concept can be for enhancing your own AI applications. You probably already know this, but LLMs, large language models, are trained on massive amounts of data. Once they are made available, these models, as powerful as they are, can't actually learn anything new. Their knowledge base is static, often outdated, and doesn't include internal data, like the specific information from your own company. That's where RAG, or Retrieval Augmented Generation, comes in. It's a way to add fresh, relevant data using two main components, a retriever and a generator. To keep it simple, when you give a prompt to the LLM, the retriever looks for useful information from documents, databases, or other external sources. Then the generator takes the information and uses it to give a much more accurate, context-aware response. The best part, RAG doesn't require training the model, it's cost-efficient, works with multiple data sources, gives fact-based answers, and even lets users check the documents it used for the responses. So you can actually verify the answers instead of just trusting them blindly. When the user asks a question, the process starts with the retriever. The retriever dives into the knowledge base and searches for the most relevant information. It then sends the top-ranked results over to the LLM. Now, the LLM doesn't just work with the questions, it also gets the context from those relevant documents. So by using this combination of the prompt and the additional data, the generator creates a more precise and tailored response. What's great about this approach is that the model isn't just guessing or relying on its own training, it's pulling in specific verifiable sources to enrich its answers. This makes responses not only more accurate but also trustworthy, because you can trust them back to the original data. Setting up a RAG starts with building a knowledge base. This usually involves using an embedding model, which is an algorithm designed to turn text into numerical vectors. These vectors are essentially mathematical representations of words or phrases in a multidimensional space, often as many as 1536 dimensions. What's cool about this is that the model doesn't just look for exact word matches. Instead, it understands and groups words by meaning, which makes it much better at finding relevant information based on context. It even breaks language barriers, so you could ask a question in French, for instance, while the knowledge base is entirely in English. Each vector is linked to the original document, and all of this is stored in a vector database. And this process is repeated for every document that's added to your knowledge base. Once your knowledge base is set up, the real magic begins with retrieval and context augmentations. Here's how it works step by step. First, the user's query is converted into a vector using the same embedding model that was used to build the knowledge base. This vector is then used to query the vector database, which retrieves the most relevant documents. The text from the most relevant document combined with the original question is used to create a new prompt, something like answer the user's question using the document provided. And finally, this prompt is sent to the LLM, which generates a precise and context-aware response to deliver to the user. And just like that, you have got an intelligent system that bridges the gap between static knowledge and real-time context-driven answers. As mentioned in the introduction, today we are going to revisit my app that generates hiking trail ideas. If you have seen my previous video, you are already familiar with the concept. If not, I recommend checking out to refresh your memory. As you can see on the screen, I've prepared a file with several hiking trail ideas. I've made sure it's as clear as possible, though a better approach would have been to store these parameters in a database like a SQL or Cosmos DB. But for the demo, I want to be as simple as possible. Okay, let's start by creating a resource group for our demo. Next, we'll create an Azure OpenAI service. We will also create an Azure OpenAI Search service in the same region as our Azure OpenAI one. This service will be the retriever we need to get our answers. We'll stick with the default settings for now. While we are at it, let's also create a storage account. Now that our storage account is provisioned, we can create a container to store our various hiking trails. I will now upload my hikes.txt file. Next, let's head over to Azure OpenAI Studio. We need to create an embedding deployment to vectorize our data and questions. Now that's set up, let's go back to the AI Search service. Simply click on the Import and Vectorize Data button. We add our storage account and container here. We choose our embedding deployment. As you can see, we can also extract text from PDF files or vectorize images if needed. I will leave the semantic ranker enabled to ensure the best results. And for this demo, I will set the scheduling to once. Let's kick off the vectorization. You can see the creation of our index, just as explained earlier. Now, let's go directly to the Azure OpenAI service to configure our RAG. We will create a deployment to test our project. In the playground, we increase the temperature to 1 to minimize creativity. We will also add our data via the Add a Data Source menu. We select AI Search and choose our index. In our case, we will leave the semantic search enabled, use the API method for speed, and add our data source. In the system message, I provide context to ensure high-quality responses. You will find all this in my lab linked in the video description. Next, I give it a prompt to suggest hiking ideas, 15 km, 500 elevation gain for instance. And there you go, it suggests 3 hikes, all taken directly from my hikes.txt file. Of course, you can do exactly what I just showed you with code. I will add the link in the video description, but you will see there is really nothing complicated about it. For more advanced scenario, we'll need to rely on another component called an orchestrator, but it's a new topic that we won't discuss today. Now it's your turn. Try to create a RAG and let me know in the comments if you have been able to do it. Maybe you can try with PDFs or images and leverage other AI services like OCR with Azure Vision. That would be even more challenging. In the next video, I will show you how I saved a lot of time writing my monthly blog post using Azure OpenAI. Don't forget to subscribe to make sure you won't miss it. Thank you all for your support. See you next time and take care. Hey, thank you so much for dropping by my channel today. Here are some other videos that may interest you. Don't forget to hit the subscribe button to be informed of the weekly updates. Let's keep growing a fantastic learning community together. My goal is to assist as many people as possible on their cloud and DevOps learning journey. That's it, take care and see you next time.